Hello and welcome to another video. In this video, we're going to be working on minimum operations to exceed threshold value 2. The first problem was really easy, so let's just start with this one. The first problem is literally just count all the numbers that are less than k in this contest. So in this one, it's kind of similar. You're given an array again and an integer k, and in one operation, you can take the two smallest integers, remove them, and then add the minimum of the two numbers times 2 plus the max anywhere in the array. Note that you can only do this operation if nums contains at least 2 elements. Return the minimum number of operations needed that elements in the array are greater than or equal to k. So in this first example, they kind of show you what they do. So you take 1 and 2 and that produces 3. Then you take 3 and 4 and that produces 10. And then you're done. Then in the second example, kind of same thing. So you take 1 and 1 produces 3. Then you take 2 and 3 produces 7. Then you take 7 and 4 produces 15. And then you take 15 and 9, you get 33. So this one is also a little bit straightforward. So let's just say we have like some numbers. Like let's say we have like whatever numbers, it doesn't really matter. So let's just make an array of a bunch of numbers. And let's just have our numbers sorted already just to make it easier. So let's say we have like 1, 3, 5, 6, 9, 11, something, 13, 14, 20, and 40. And let's say k is like 20 here. So I think the reason that this problem's easy, that I misread it a little bit, is at first I thought you can take any two numbers and then you can do this operation. And then I was like, well, which ones are the best to take? But because you can only take the two smallest, it actually becomes pretty simple because you don't really have to figure out like, what do I take? Like you always know you have to take the two smallest. So you basically just need to think like, what data structure can I have that will efficiently allow me to take the two smallest numbers and like get rid of them really quickly, right? And then put in another number and then get the two smallest and so on. And so the best data structure to get, or at least one of the good ones, to get the smallest number is a heap. And because this is, the constraint is 10 to the 5th, essentially, worst case scenario, you would have to do this like n log n for a heap, which is fine because like log of this is like 50 or something, which will easily pass, right? For basically all constraints that are around 10 to the 5th, if you have an n log n solution, it's fine. So this is pretty easy. Like all you have to do is like, let's say we have this in a heap. And I'm just going to show like, let's say this is a min heap. And instead of having these indices, I wonder if I can actually get rid of them. I think so. So let's say this is our heap. So all we literally have to do is like, we get our two smallest numbers and then we perform this operation. So we take 2 times the min plus the max. So 2 times the min plus the max here is going to be 2 plus 3. So we'll get 5, right? So we can just change this into a 5, throw this out, and put it into our heap. Now, the two smallest again is this. Then we do the same thing. So 2 times the min is 10, plus 5 is 15. So that would go here in our heap. Actually, so technically the heap isn't completely sorted, right? Because it's a heap, but let's just say it is. So it would look something like this. Obviously, like I said, the order won't be exactly this. The smallest element will be maintained though. Then we take our two smallest again, and we do the same operation. So we get 12 plus 9, which is 21. So then we put it somewhere in our heap. Let's just say it's over here. Doesn't really matter. And then we take two smallest again. And we do the operation again, so we get 22 plus 13, which is 35. So put that in our heap somewhere as well. Then we take two smallest again, and this is the last time we have to do this. And you do this operation again, and you get 28 plus 15, which is 43, I believe. So hopefully I did the math right, but even if I didn't, the actual logic part of it is fine. So basically, anytime you do this operation, you just store that in a result, right? You take the two smallest elements, you just heap pop them from your heap, and then you keep doing that until the min heap value is greater than or equal to k, because that's what we're looking for, right? So we're looking for, Takes the smallest, return the minimum number of operations needed, such that all elements are greater than or equal to k. So you literally just have a basic heap, pop the two smallest elements, do this operation, right? So just take the min times 2 and max. And the other thing is also, because you're going to pop two elements, you know that, like, because it's a heap, you know that the first one will be the min and the second one will be the max, or they'll be equal. But either way, you can, like, the second one will always be the max, right? So you don't even need to check, like, which one's the min, because you have a min heap. And that's basically it. So we can code that pretty easy. So we can just take nums. We don't need to modify input. We can just make a copy. So we can just say, like, heap equals copy of nums. And then we heapify it because it's not necessarily in sorted order or anything. So heap. We have a result variable. Then we would just say, and they also told you, like, there's always a valid solution. So in the constraints. So we don't have to worry about, like, our heap being empty, because if there's always a valid solution, then the smallest item has to be greater than or equal to k when we're done. So while heap 0 is less than k, we can just pop our two items. So we can just say, like, x equals heap pop heap first, and then second item will be heap pop heap again. And we know that x is smaller than y because we have a min heap. So all we have to do is just do this operation, put it back into the heap. So we can heap push into our heap, and we just do 2 times x plus y, which is the operation, and we increment result. Then finally, we return result at the end. And this is not lined up correctly, so there we go. Okay. And yeah, pretty easy. So I was actually really confused why this only had, like, a 20% acceptance rate, because I think this is a pretty easy problem, like, honestly, even closer to an easy than it is to a medium. So I'm curious if you guys have any thoughts on what was difficult. Let me know there. And then yeah, so time here is n log n, and space is of n, because we just take our array and turn it into a heap. And yeah, I think that's gonna be all for this one. And I'll probably try to spread out the solutions to these contests in a little bit more days. I think just doing, like, 8 problems in one day is a little too much. So I'll spread them out during the week. So I'll probably do, like, 1 or 2 problems a day, along with the daily problems. So yeah. And if you did like this video, please like it as always, and please subscribe to the channel. I think we're close to 1,000 subs. So thanks to you guys for that. And I'll see you in the next one. Thanks for watching.